We're going through section 2.4 and 2.5. We're talking about linear functions and equations of lines. So far we had a definition of a linear function and a definition of slope, and we learned about point-slope form for the equation of a line and slope-intercept form for the equation of a line. And then in example 1 we graphed several lines. And so now what I'd like to do is I'd like to go on to example 2, which just says look back at the graphs from example 1 and give the domain and the range for each of those lines. So let's go back up here and let's talk about domain and range. Now this is a review from the previous section, from section 2.3, where we already introduced this idea. So we can look at the graph and we can see that the domain is negative infinity to positive infinity. Remember, domain is the set of all possible inputs or all possible x values. And so when we see the line extending forever to the left and to the right, then we know the domain is all real numbers. And we can write that in interval notation as I've just done. We can see that the range is also all real numbers, because the line extends down to negative infinity in the y direction and up to positive infinity in the y direction. So domain and range. We could also get the domain and range just by looking at the formula. We can ask ourselves for the domain, we can ask, is it possible to put any number in for x? Can we multiply any number by -2 and then add 3? And the answer is yes. And so domain is all real numbers. In the previous section, we saw a couple examples where there were some restrictions on the domain, where not any number would work. But just for a little multiplication and a little addition, any real number is fine. And so there's our domain. Okay, in example 1b, the answers would be the same for the same reasons. Negative infinity to infinity for the domain and the range. And it might be helpful if we knew that the equation could be rewritten as positive 3/4 x is equal to y. We did that in the previous video. Okay, in the two special cases, for the horizontal and the vertical lines, the answers are just a little bit different. So this time, when we look at part C, if we just look at the formula, what does it say? It says y must be equal to 3, and furthermore, y can only be equal to 3. And so, of course, y is, the y values are the range. And so the range only has one value, and that's 3. And so we can't even use interval notation. We have to use set notation to describe that one discrete value. We use interval notation to describe a continuum of inputs or outputs. All the numbers from negative infinity to infinity can be in the domain. So there's no restriction on the x value, only on the y value. We can see that in the graph as well. From left to right, x values go from negative infinity to positive infinity, but in the y direction, there's only one y value, it's 3. And so the last equation is x equals 3, and the answer would be similar. This time it's the domain that only takes one value, and it's the range that can be any real number. It's worth mentioning one other thing here. This equation x equals 3 is not a function. is not a function. You can see that because the input 3 has more than one output. The input 3 has an infinite number of outputs. And so therefore not a function. The previous examples were functions. Okay, so we've done the domain and the range, and now let's go on to example 3. And let's see here. We're going to start with the graph, and we're going to write the equation of the line. That's just the reverse of what we did in the example number 1, right? In the example number 1, we were given the equation and asked to find the graph. So probably we should think of the formula y equals mx plus b. And then if we can just find a value for m and a value for b, then we should be good. So b, let's start with b. b is the y-intercept. And so you see that the y-intercept is at the point 0, 1. So b is equal to 1. And the slope, well, we can determine the slope if we just count from one point on the line to another point. We want to try to find another point that's on the line that falls on the grid lines of the graph paper. And so the point at 3, -1 would be good. Another possibility would be this point back here at -3, +3. Choose 2 points. And then we need to count a rise and a run. To go from left to right, we're going to start at this point and we're going to go down 2 and then right 1, 2, 3. And so rise over run would be down 2, would be -2, and the run is a +3. So the slope is -2/3. And so we can go ahead and write our answer, y equals -2/3 times x plus 1. And we're done. Okay, one more like this. You might pause the video and try to do it for yourself. Students often make a mistake on this example 3b because they might forget to look at the scale on the graph. Usually each grid line represents 1 unit, but now you can see in the x direction we're actually counting by 5s, and in the y direction we're counting by 50. So we have to be real careful there. So it might be good to just go ahead and label a few more tick marks along the x-axis and also on the y-axis. Where is the y-intercept? The y-intercept is at -100. And to get the slope, we can count from that y-intercept up to the point at 5, 0. How far up do we go? From -100 up to 0, we went up 100, so that's a positive. And to the right, 5. So that's a rise over a run, gives us a slope of 20. And so we can go ahead and write our answer, mx plus b, 20 times x minus 100. And there's the equation of the line. This might be a good moment to remind you that when you look at a linear function, if the function is increasing, from left to right, then the slope must be positive. And so we see that in this example B. And if the line is decreasing from left to right, then the slope must be negative. And we see that in example A.